So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture, we are going to see how to solve a subarray sub-question. So let's take an array which has the element 1, 7, 3 and 2. Now in the previous lecture, we have seen that how to find the subarray from this array, right? Now let's try to find out the subarray of this array. It will be 1, 1, 7, 1, 7, 3, 1, 7, 3, 2, 7, 7, 3, 7, 3, 2, 3, 3, 2, and then 2. Now, if you don't know what is actually a subarray, I recommend you to please watch the lecture on subarray that I have created. The link is in the description as well as in the I tab. Now, they are asking us to find the sum, right? So, if we calculate the sum of every single subarray, this will be 1, 8, 11, 13, then this will be 7, 10, 12, 3, 5 and 10 2, right? So they are asking us to find the sum of all the subarrays and we have to return it in the form of an array. So let's say we will be creating the resultant array and here will be storing all the sums, right? Now the question is that what might be the size of the resultant array? If you have watched the previous lecture, I have told you that if you want to find the number of subarrays when the array size is n, the formula will be n into n plus 1 by 2. Here the n is nothing but a size of an array. So for this array, the size is 4, right? So 4 into 5 by 2. So that will be 10. So number of subarrays when the array size is 4 will be 10. So we have to create the resultant array of size 10. Okay. Now let's see that how we can find this sum. But before that, let me tell you that we have started a series on DSA problem. If you know the fundamentals of DSA but getting stuck while solving the DSA problem, this series will be very helpful for you. If you're preparing for the placement and interviews, you can visit to this playlist. The link is in the description box. Let's see that how we can find this sum. So approach 1, if you know how to find all the subarrays, then this approach 1 will be very easy. So if you want to find all the subarrays, we will be using 3 for loops, right? Here I'm taking the help of the start variable, which will be running from 0 and it will be going till n. Now in the inner for loop, the variable will be end, which will be starting from start variable and it will be going till n. Now there will be a variable k which start from start variable and it will be going till end. Okay, now we have to iterate it. Now inside this we usually have to print the subarrays, right? But since we want to find the sum, what we will be doing, we will be calculating the sum. So sum plus equals to a of k. Now we know that after every iteration the sum is different, right? So in the inner for loop, I'll initialize the sum to 0 always. That's it. Now the sum should be stored in the resultant variable. So resultant I plus plus is equals to sum. Now let's create the result variable, resultant array. So first of all, we have to create the number of subarrays. So integer number of subarrays will be n into n plus 1 whole divided by 2, right? Now let's create the resultant array is equals to new int, and the size of the array will be number of subarrays. That's it. Here we have created the resultant array, and using this code we will be able to find the sum of all the subarrays. Now let's try run this code with the smaller array. So let's take array as 1 7 and 3. The indices are 0 1 2. Now let's start with the for loop. Start will be running from 0 and end will be running from start, that will be 0, right? Now inside this we have sum, and we have to iterate from start to end using the k variable, which is easy, right? So k will be running from 0 to 0 because we have to iterate from start to end, right? So 0 to 0. So from 0 to 0 there is only one element, so the sum will be 1, right? Let's increment the end again. The k has to iterate from start to end, that will be 0 to 1. Now if we iterate from 0 to 1, the sum will be 8. Okay, similarly let's increment our end, that will be 2. Again k will be running from 0 to 2. So from 0 to 2 we are calculating this sum, right? So it will be 11, right? Now that's it. So the inner for loop will end and the start will get incremented. The value of start will be 1 and end will be running from start, that will be 1. So my k will be running from 1 to 1. Now 1 to 1 there is only single element, that is 7. So sum will be 7, right? Let's increment the end, that will be 2. So k will be running from 1 to 2, 1 to 2, only two elements, that is 7 and 3. Therefore sum will be 10, right? Now here the inner for loop will end and my start will be 2. Now end will be, that is start 2. So k will be running from 2 to 2, 2 to 2, only single element, that is 3. So the sum will be 3. Okay, now what you can do after inner for loop, you can have the variable, that is I, and here we have to initialize the I to 0, and result of I is equals to sum. So you can store all this value in the resultant array like this. Now let's try to find the time complexity. We can see that there are 3 for loops, this one, and this one, and all are running approximate to n, right? So due to that it will be order of n cube, and the space complexity will be order of 1 because we didn't take any extra space. Now we know that this time complexity is used, so let's try to minimize this. Now if you try to optimize any approach or any solution, the only thing will help is observation. So let's try to observe this. I will bring all the subarrays here. Now for timing, let's try to see whether the prefix sum approach will help us or not. Let's try to create the prefix sum. It will be 1, 8, 11, and then 13. So if you don't know the prefix sum, just remember this. We are calculating the sum at a given point. So this sum at this point will be 1 because it contains only single element. The sum at this point will be 1 plus 7, that will be 8. The sum till this point is 11. It is actually 1 plus 7 plus 3, and the sum till this point will be 13. That is 1, 7 plus 3 plus 2. Now what you can do now, till this point you have sum which is 8, right? And if you want to find the sum, that is 11, you can simply do 8 plus 3, that will give us 11. Similarly, if you do 11 plus 2 will give us 13. So this is nothing but a prefix sum approach. Now if you observe 1, 8, 11 and 13, all these elements are matching with this element, right? So these 4 subarray are starting with a of 0. These 3 subarrays are starting with a of 1. These 2 subarrays are starting with a of 2, and these are starting with a of 3, right? Now this is simple, right? The prefix sum array is actually matching with this. But what about this 7, 10 and 12? Now if we observe, now if we are talking about this 7, we are not including this 1. If we are talking about this 7, 3, we are not including this 1, right? Similarly, if we are talking about this 7, 3, 2, we are not including this 1, right? Now for till index 1, this sum is 8. What does 8 means? It means 1 plus 7. So if I exclude this 1 from 8, I will be getting 7 as my answer, right? Which is this, right? Similarly, if we are talking about this 7 and 3, that is a second subarray which is starting from a of 1. Now we have the sum that is 11, and what does that mean? The sum of these elements, right? And we don't want this element, so simply subtract 1 from 11, we will get answer as 10. Similarly, if I want to find the sum of 732, till this point we have the sum as 13, right? And what does 13 means? The sum of every element, right? But we don't want this one, simply subtract 1 from 13, so we will be getting 12 as the answer, right? Let's go further. Now if I want to find the sum of this subarray, which is 3, I'm talking about this. Now for this 3, the prefix sum is 11, right? And what does that mean? It means the sum of all this element, right? And we don't want this, we want to exclude this 1 and 7, and the sum of 1 plus 7 is already present here, so simply subtract 8 from 11 and we will be getting answer as 3, right? Similarly, if we are talking about this 3 and 2, here this sum, the prefix sum is actually stored here 13. And what does that mean? It means the sum of all elements, right? But we don't want this 1 and 7, and the sum of this 1 and 7 is located here, so simply subtract 8 from 13 and we will be getting answer as 5. All right, that's it. This is the approach. The pseudocode will look like this. For start will be running from 0 to n, and for end will be running from start to n. Okay, now if my start is 0, I don't have to subtract anything, because if my start is 0, we can see that the answers are already present in the prefix sum, right? So my result of I plus plus will be simply pf of end. Okay, but before that we have to create the prefix sum array. Okay, if my start is not equals to 0, at that time we have to do some subtraction. So result of I plus plus will be pf of end minus pf of start minus 1, and that's it. This will be our optimized pseudocode. Let's try to try run it with 3 elements: 1, 7 and 3. Indices are 0, 1 and 2. The prefix sum will look like this: 1, 8 and then 11. Right now start will be 0 and end will be also 0. If my start is equals to 0, I simply have to store prefix sum of end, right? And prefix sum of end, the value of end is 0, so 1 will be my answer. So I am storing in the resultant array as 1. Now let's increment the end, that will be 1. Again, here also the start is 0, right? Start is 0, so simply store prefix sum of end, that will be pf of 1, that will be 8. Again, increment the end, store pf of 2, that will be 11. Right, till this point everything is easy. Now the inner loop will end and I'll increment the start, that will be 1. My end will be start from start, that will be 1. Now from 1 to 1, the sum is 7, right? So let's try to find out. Here we can see that the start is not equals to 0, right? Start is not equals to 0, so else condition will execute. So else part will execute. Now it says that pf of end, pf of 1, that will be 8, minus pf of start minus 1, that will be 0 minus 1, right? The value of this is nothing but 1, so simply subtract 1 from 8 and we will get our answer as 7. So 7 is getting stored. Let's increment the end, that will be 2. Again, else case will execute pf of end, that is pf of 2, that is 11, minus pf of start minus 1, that will be 1. So answer will be 10, right? If we try to find out the sum of these two, that will be 10. So 10 will get stored, right? The inner loop will over and we will be incrementing the start, that will be 2. End will be 2. So we have to run from 2 to 2. From 2 to 2, we know that there is only single element, that is 3. So 3 should be my answer. Let's try to find out. Again, start is not equals to 0. So my else condition, else case will execute. It says pf of end, the value of end is 2. So that will be 11, minus pf of start minus 1. 2 minus 1 will be 1, right? So simply subtract 8 from 11, that will be 3. So I'll show 3, right? That's it. So we are done. We are done. Now what we have done in this approach, we have actually eliminated this for loop. Okay, so due to this, the n which was actually containing here was eliminated. So due to that, the optimized approach will have only 2 for loops. So due to that, the time complexity of this approach will be order of n square. We can see that we have only 2 for loops. Okay, and inside this for loop we have this if and else, which will be constant. Now, if we talk about this space complexity, it will be order of n. Why? Because we have taken the help of extra space, that is prefix sum, right? So due to that, this will be order of n. But yes, what you can do, if the array is not final, you can manipulate or you can create this prefix sum inside the original array only. At that time, the space complexity will be order of 1. Okay, but only in case if the original array is not final, right? This is the approach to which is optimized. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing.